So with any other function, it's important for us to take a look at the parent functions. So right now, what I have is a square root of x and cubic root of x. We're gonna go ahead and take a look at what these graphs would look like first. So I went ahead, made a very simple table. So if x is 0, y would be 0. We're looking at square root of x, by the way. And when x is 1, then we're going to have two roots, right? We could have our function of x could be plus or minus 1, correct? Because positive 1 square would give us 1, and negative 1 square would also give us 1. And we have x equals 4, which would also give us plus minus 2. So once I plot these points, I can go ahead, graph them like so. Oh, but here's a little problem because it does not pass the vertical line testing. Therefore, this is not a function. My domain seems to be that x is all positive, right? So x values would have to be bigger than or equal to 0. So they cannot, my x values cannot be negative at this point. In this case, what we have to do is go ahead, take a look at my range. My range technically is all real values, right? So that's why we have y values to be plus minus 1 or plus minus 2. But what if I go ahead and say that we are only interested in the values of y that are bigger than or equal to 0, just like what our domain is. So let's go ahead and say that my x would have to be bigger than or equal to 0, and my y would also have to be bigger than or equal to 0, which means all of my negative 1 and negative 2 would no longer be valid. Now, this passes the vertical line testing, therefore this is a function. So our square root of x kind of looks like a parabola that's been rotated 90 degrees and half of it cut off. And that's because we want to make sure by limiting our domain and range that it becomes a function indeed. Then what about the cubic root of x? For this particular function, I've selected x equals to be 0, 1, and negative 1, and obviously my y values would be 0, 1, negative, and negative 1 respectively. So I'm going to go ahead, graph, and what I end up getting is something like this. And I can go ahead, do vertical line testing, and this passes the vertical line testing, so therefore there's no need for us to limit or specify particular domain and range, right? So our domain would be bigger than, our domain would be all real numbers, and our range would be all real numbers as well. So now let's see how we can apply transformations to these parent functions to graph some of the examples that we have in our workbook. Let's take a look at the very first one, which is square root of x minus 2. So to the parent function that we have, I'm going to go ahead and minus 2. So this already tells me that all of my y values are going to be shifted by negative 2 units, right? Now, if I were to plot my new set of points, I would get 0, negative 2, 1, minus 1, and 4, 0. So this is what I end up getting from our parent function. The whole graph shifted vertically by 2 units, negative 2 units. And that means our domain in range also changed. For my domain, we are only interested in x values that are positive, so that's okay. But what about our range? We initially said our range was all y values that are equal to or bigger than 0. But in this case, our minimum y value would be negative 2. So therefore, my range should be y is bigger than or equal to, or in this case actually should be function of x. So function of x is bigger than or equal to negative 2. And let's take a look at our next example. This time, our negative 2 is not added as a constant, but it is actually added to x. So it sits under the radical. So I'm going to go ahead, change that, x minus 2. So let's go ahead use yellow to graph this. When x is 2, y is 0, and x is 3, y is 1. And when x is 2, 3, 4, 5, 6, x is 2. So as you can see, our entire graph shifted by this time positive 2 units horizontally. So now let's take a look at number 3. We have 3 times square root of x plus 2 points that we're working with. So let's go ahead, plot these. This is what I get. So if you think about it, what is our domain? Our domain is still all positive values of x, right? So our domain would have to be all positive values, but that are bigger than or equal to negative 1. So x is bigger than or equal to negative 1. And what about my range? My range is all positive values. So range is all positive values that are bigger than or equal to 0. Okay, let's take a look at one more square root function. This was actually number 3, but we're going to take a look at number 6. What our graph ends up looking like. Remember, if we were to compare it to our parent function had a graph that looked like this. So what happened? It not only shifted horizontally by positive 3 units, we also reflected. There was a reflection that happened about our x-axis. Cubic root of x plus 1. So again, or to make a simple table, when x is 0, y would be 1. And when x is positive 1, I would get 2. And when x is negative 1, with the cubic root, we could have negative, if it's negative 1, we would get negative 1, right? But in this case, negative 1 plus 1, so it would be 0. Our graph would look something like this. Now remember, our parent function looked something more like this, correct? So what do we notice? We notice that the entire graph shifted vertically by positive 1 unit. Which means my domain and range is also probably affected. But my domain would be, now we could encompass all negative and positive real numbers. So domain is negative infinity to positive infinity, and my range would also be negative infinity to positive infinity. And my vertical shift actually did not have any impact on my domain and range. But let's take a look at number 8, when we have x minus 4. So now we know that this means horizontal shift. So when x is 4, y would be 0. And when x is, let's say, 3, my y would be negative 1. And when x is 5, I will get, positive 1. So if I were to graph it, (3, -1, 4, 0). So what I end up getting is something like this, where the entire graph now shifted horizontally, not by -4 units, but remember, we have to think about reverting our square root of x. The question that we must ask is, what would the value of x have to be in order for us to revert square root of x minus 4 back to square root of x? And that means our x would have to be 4, right? So that means there was a horizontal shift by positive 4 units. All right. And again, there was no real impact on our domain and range at the moment. But let's go ahead and take a look at number 11. We have negative cube root minus 1. So there is reflection and vertical shift happening. So when x is 0, y is negative 1. 0, y is negative 1. And yes, negative 1. And when x is, let's say, positive 1, then I would get negative 2. And when x is negative 1, then I'll get 0. So let's go ahead and plot that. So when x is 1, my y value is negative 2. When x is 0, it's negative 1. And when x is negative 1, y is 0. So this is a graph that I end up getting, and as you can see, we can clearly see that compared to the parent function, which is in blue, there is clear line of reflection, but not at x-axis. This time my line of reflection is actually at y equals -1, because even the line of reflection was shifted vertically by -1. So in this case, obviously reflection took place first and then the translation, vertical translation. So this is reflection over x-axis, and then vertical translation by -1.